So the version that I got looks like this, and to try to figure out what's going on here, I think we should pause for a minute and look at the graph.
So here's the integrand, and let's take a look at its graph. So here it is, and so we can see that there's an asymptote. If you look at the function, when x is equal to 1.5, 2 times 1.5 is 3, and 3 minus 3 is 0. So there's a 0 in the denominator when x is equal to 1.5, and we can see that on the graph right here. So what should we do? Let's just change the window a little bit. So it looks like, yeah, this is good. So here we see the asymptote, but the integral only asks us to go up to 1. So we don't have to worry about this point of discontinuity because it's to the right of the right bound of the integral, which is going to go right here. So so that's what's going on. So the issue here is what is happening back here. Is the area under this curve a finite area, or are we talking about an infinite area?
Okay, now that we know what's going on, we see that the only place where this thing is improper is out to the left. So we need to replace that left boundary, we'll call it A since it's on the left, with the variable A. And so we'll look at this integral, and I'm going to write the integrand as 3 times 2x minus 3 to the negative 2, okay? Then I can make u equal to 2x minus 3, and then du is 2 dx. You remember substitution, right? And so I'll throw a 2 in here and a 1/2 out here. And then the whole mess looks like this. The limit as a goes out to the left of, here's the 3/2, this 3/2, and then the integral of u to the negative 2. My phone's going off. Who knows what's going on? So to integrate this, if we add 1 to the power, we get a -1. The reciprocal of that is also -1. So the limit as a gets big and negative of 3/2 times negative u to the negative 1/2. But u is 2x minus 3. So I'm sort of saving a step here. And that needs to be evaluated between a and 1. Okay? So I'm going to get the, what? I think I'll get the 3/2 out of the way. 3/2 times the limit as a goes out to the left. When I plug in a 1, I get -1 over 2 times 1 minus 3. Right, because the -1 here means I can move this down to the denominator. Subtract -1 divided by 2 times a minus 3. So check this. So this is plus, right? So 2 times something enormous and negative minus 3. So we have a very giant negative quantity down here. So that whole thing is going to go to 0. So the value of the limit just depends on this thing. So we get 3/2 times -1. This is 2 times 1 is 2. 2 minus 3 is a -1. So the value of the limit is 3/2.